And then let's go with the cotangent. So cotangent of the negative x will be just use the reciprocal identity. This is equal to 1 over the tangent of the negative x. And we just have seen this tangent is an odd function. So this guy is equal to negative tangent of x, right? So 1 over the negative tangent of x. And this is equal to negative 1 over tangent x. And 1 over tangent x is equal to cotangent x. So this is equal to negative cotangent of x. So cotangent is also an odd function. And let's look at the secant of the negative x, which is equal to 1 over cosine of the negative x. So cosine is even function, so this is equal to 1 over the cosine of x. And then this is equal to secant of x. Okay. And the cosecant, which is equal to 1 over sine of the negative x, and sine is odd function, so this is equal to negative cosecant of x. So now we have this odd identities and even identities. Odd sine of the negative x is equal to negative sine of x. Cosecant of the negative x is equal to negative cosecant of x. Right. And then tangent of the negative x is equal to negative tangent of x. And cotangent of the negative x is equal to negative cotangent of x. And for this odd function, okay, for this odd functions, for this odd identities, we know the graphs of the odd function are symmetric about the origin. Right? For example, we have this odd function f of x equal to x cubed, and its graph is like this. Right? And this graph is symmetric about the origin. Okay? So this is an important property about the graph of odd functions. Now let's look at the even identity. Okay, we have these two even identities. Cosine of the negative x is equal to cosine x, and secant of the negative x is equal to secant x. Okay. And we know the graph of an even function is symmetric about the y-axis, right? For example, we have the f of x equal to x squared. This is an even function, and we know this is a parabola. So the graph is like this, right? So it's symmetric about the y-axis. Okay. Now let's try to use this odd and even identities to simplify some expressions. Let's look at the page 517, problem 42. So let me copy this problem in here. (517) from 42, we have the cosine of the negative x over sine of negative x minus cosine of negative x over sine of x. So first, cosine is odd or even? Odd or even? Even, right? So the cosine of the negative x is equal to the cosine x. So when we just replace this by the cosine of x. Then for the sine, odd or even? Odd, right? Then you replace the sine of the negative x by negative sine of x. So similarly, for this part, you have the cosine of x over the sine x. And then you may use the identities from the definitions. You know, this cosine over sine is equal to cotangent, right? So you have the negative cotangent of x minus the cotangent of x. And then in this way, you get negative 2 times cotangent of x. Okay, then down. Now let's look at the one example on the book. And let's look at the page 513, example 5, part B. Okay, let me copy this problem on the whiteboard.